Hello, dear students. This is Dr. Sourav sir's class. We are now solving our NBHM PhD paper from 2012. Hope you are doing well and studying hard for your examinations. So, what the question says us, the question is from linear algebra. So, the question tells us that let A n be an n-cross-n matrix whose ijth entry, that means our Aij is equals to 2 delta ij minus delta I plus 1 comma j and minus delta I comma j plus 1. Okay, now where our delta ij is what? Delta ij is known as Kronecker delta function. We all know that is equals to 1 our if I is equals to j and 0 if I is not equals to j. Now we have to compute the determinant of an. So firstly we are trying to draw the matrix. So let us take a2 cross 2 first. Then what we will get? Then we have the first entry will be my a11. That will be our delta ij is 1, so it is 2 minus 0 minus 0, so that is equals to 2. So our first entry is 2. Now what will be the a12? Then del ij is equal, del 12 is 0, and the second term that will be del 22. The del 22 will be 1, so it is our minus 0 minus 1, and the last term is 0. So yeah, that is our 1 minute. My pen is not working. Yeah, okay. So it is our minus 1, and now so our a12 position will be minus 1, and we are finding a21. So similar thing will happen, and del 21 is equals to 0, so that is 0, and that will also be 0, and that is minus 1, so it is minus 1 here, and a22 is equals to 2. So minus 1 and 2. That is my A22. Now we are trying to find our ANN. ANN. Then our first entries are this. Yeah. Then what will be my this position? That means it's A13. So A13 will be here for del 13 is 0, and that is my del 23, that will also be 0, and that is my del 14, so it will be 0. Okay, and similarly my a31 will also be 0, that is 0. So now we have to find that a23 position, a23. Then a23 will be, for this case our a23 will be minus 1. Here is minus 1, and similarly that is minus 1. So our matrix is this, and that is minus 1. Here will be minus 1, here is 0, here is 0, upper 0. Yeah, yeah. Here is minus 1, 0, and the minus 1 are here. And the sub diagonal and super diagonal, that means the upper diagonal of the diagonal is super diagonal, and the lower diagonal is of the diagonal is our sub diagonal. Entries are minus 1. And now what can be done? Now we can use this thing. Okay, we have to use here del ak is minus del ak minus 1, which is equals to my del ak minus 1 minus del ak minus 2. Yeah, This gives us del A equals to del 2 del A k minus 1 minus del A k minus 2. Okay. So now what will we get? Okay. So we have to prove this, no? Then we can use it. So we are trying to use mathematical induction here, as we know that our, let me change my color to blue. Okay. As our A2 cross 2 is equals to 2 minus 1 and 2. So our del A will be, del A2 is now equals to my 4 minus 1, that is 3. That can be written as this 2 plus 1. Then let it be true. Let it be true for k less than equals to n minus 1, and that is my del AK is equals to k plus 1. This is the P1 statement. Let that the statement be my Pn1 Pn minus 1 system, a statement. K equal to 1 for all k less than equals to n minus 1. Then what will happen? Then for k equals to n, we have, now we are going to the deep induction. We have our del AK, which is equals to our 2 del AK minus 1 minus del K minus 2. We got this from the Laplace expansion twice, using Laplace expansion twice. Okay. So what will happen? So that is equals to my 2 of k minus k minus 1. That is my 2k minus k plus 1. So it is my k plus 1. Okay. So we were trying to prove that my det AK is equals to k plus 1. So we got det AK is equals to k plus 1. So that means, therefore, the golden result is our determinant of an in this kind, that will be n plus 1. Yeah. We used the Laplace expansion twice, which is this in this question. So we get the answer that our delta n, del n, sorry, determinant of n is this, as our an is this. So the correct answer of this question is now n plus 1. Okay. Thank you guys.